purpose of this video is to define matter, talk about how we measure matter in terms of mass and volume, and also how we measure density of matter. I decided to start the video with this picture. This picture was taken in 2013. It's a redshift map of the leftover radiation from the Big Bang. If you think about it, all the matter that we will ever know is inside this ellipsoid. So when we're talking about matter, we're talking about everything inside this ellipse. Definitions. Matter is anything that takes up space and has mass. This is the most simplistic definition of mass that we know. If something takes up space, we say it has volume. If something has mass, we can say that a gravitational force can work upon that object. That's kind of the physics definition of mass. However, in chemistry, we just kind of think about mass as a measure of how much matter is inside an object. So there's a few units of measure that you need to be able to use in chemistry. The first one is the liter. So a liter is what we call the International Scientific Measure of Volume. Even though the liter is the SI unit, we usually use smaller amounts of a liquid, so we break down the liter into the milliliter. The prefix milli means 1/1000th of something, therefore a milliliter is 1/1000th of a liter. Here's a picture of a beaker that contains 125 milliliters of a liquid in a 250 milliliter beaker. You notice that it's not a whole heck of a lot of liquid inside there, so really a milliliter is probably about the size of a quarter of a dice. It's really not that much. However, when we're talking about small amounts of liquid, use the milliliter as a unit of measure. The SI, International Scientific Unit of Mass, is the gram. A gram is also a pretty small unit of measure. In comparison, a dime is approximately 1 gram. This is all review. You've seen this in other science classes. Mass is measured on a balance or a scale. Here are 3 examples of balances or scales. The first 2, the electric balance and the triple beam balance, will be used in this class, and you used them in the measurement lab. There's 2 ways to measure volume, as you saw in the measurement lab. The first way is we can measure volume geometrically. So for example, think back to the dice that you were using in the chemistry lab, in the measurement lab. A cube has the dimensions of 2 centimeters by 2 centimeters by 2 centimeters. You use your geometric equation that you learned in geometry for volume. Volume of the cube is length times width times height. If I was to solve this out, all I would do is I would have 2 times 2 times 2, which is going to be 2 cubed, which will be 8. Paying attention to sig figs, because a lot of people in the class already know what sig figs are. There's 1 significant figure in the side of a cube, so there'll be 1 significant figure in the answer, and I always put my units. The other way to measure volume is with Archimedes' principle. So we talked about Archimedes' principle also in the measurement lab. We use Archimedes' principle when we have an object that is not a perfect sphere or a perfect cube. In order to use Archimedes' principle to come up with the volume of an object, we use displacement. Down here, there are pictures, 2 graduated cylinders. The first picture is on the right-hand side here, and we measured the volume of a liquid prior to putting an object into that liquid. So for instance, here, this liquid is 11, and we can go to the 10th spot, 11.0 milliliters. Afterwards, we'll say that it's about 16.0 milliliters. To find the volume of this weird shaped rock, I take 16.0 minus 11.0, and I find that the rock has a volume of 5.0 milliliters. Again, note that I went to the 10th spot here because I can estimate halfway in between each line on the graduated cylinder. That's finding volume using displacement. Let's now talk about density. Density is a derived unit because you use non-derived units, mass and volume, to derive a density measurement. So density has the formula mass divided by volume, seen many times like D equals M over V. There's also a nice little triangle that you can use in order to help isolate a variable to solve for either mass or volume or density if you know 2 of 3 of the other variables. This triangle here is an incredibly handy tool to copy down. So this is your density triangle. Let's say here that I want to solve for mass. I want to solve for mass. I cover it up or circle it. And when I circle it, I'll put it over on the left-hand side of the equation, and I look down at the bottom of the triangle and see that mass is going to equal density times volume. So that's an easy way to rearrange the density equation in order to solve for mass. Let's say now that I want to solve for volume. If I would like to solve for volume, I circle the volume right over on the side, and I see mass divided by density. And now I've quickly rearranged that equation to solve for volume. Let's put this into practice. What volume of a silver metal will weigh exactly 2,500 grams? The density of silver is 10.5 grams per cubic centimeter. Here's the units here, mass over volume, grams over cubic centimeters. It could also be grams over milliliters. So I'm going to solve for volume. So I'm going to circle volume here. And I notice volume is going to be mass divided by density. Fill in my variables. Mass is 2,500 grams. Density is 10.5 grams per cubic centimeter. Grams can cancel out, leaving me with cubic centimeters. And then I have 2,500 divided by 10.5. And I get 238.095 and a bunch of other decimal places. Now, I haven't officially talked about significant digits yet, but I can only use as many sig figs as I have in the smallest number of sig figs in my measurement. Here I've got 2 sig figs. Those zeros are not significant. Here I have 3 sig figs. So I go 2 sig figs here, 1, 2, look after the 3, it's an 8. That moves that 3 up to a 4, so I have 240 cubic centimeters. Don't worry if you misunderstand the sig fig part of this, because we're going to have an official unit on this next week. I just want to start introducing it now so you start to get used to it. So this video covered matter, definition of matter, how to measure volume, and how to measure mass, and how to calculate density. At this point in time, you can rewind, rewatch any point of the video that you are confused about, or maybe just move forward through the homework. The assignment that goes along with this information is in your textbook. And it's page 12, numbers 1 through 6, page 16, numbers 3 through 11, page 20, numbers 3 through 7. Thank you for watching. Have a wonderful evening.